ordered pairs switch x and y. Okay, an example would be, let's say I have the relation. Let's call this relation set A. And in this relation, I have the points 1, 2, 3, 0, 4, negative 1. Now, if I want to find the inverse of this relation, so my relation is called set A. To find the inverse of this set A, I'm going to write A to the negative first power. That represents the inverse of the set. And to find the inverse, what we're going to do is we're literally flip-flopping x and y. So now the point 1, 2 becomes the point 2, 1. The point 3, 0 becomes the point 0, 3. The point 4, negative 1 becomes the point negative 1, 4. So now what happens when we find an inverse where our domain of our original becomes the range of our inverse, and the range of the original becomes the domain of the inverse. And this idea of switching our domain and range is going to be huge for us moving forward. So let's write this out. A function and its inverse switch domain and range. So the domain, if we're going through this, based on our example, the domain of A was the point or the coordinates 1, 3, 4. Do we agree? And the range of A were the points 2, 0, negative 1. Now, if we look, the domain of the inverse of A is 2, 0, negative 1. And the range of the inverse of A is 1, 3, 4. So I'll give you a second to write that down, and then I'll recap. Okay, so do we see that the domain of A becomes the range of its inverse, right? The domain of A became the range of its inverse, and the range of A became the domain of its inverse, right? We have to remember that whenever we have a function and its inverse, we are switching our domain and range. The domain of the original becomes the range of the inverse, and the range of the original becomes the domain of the inverse. Let's say you don't need graph paper for this. You don't even have to write this down. I just want to show you. Let's say I have a point, and that point is going to be -2, +1. And now the inverse of that point, right? What would be the inverse of -2, +1? We're just switching x and y, right? So the inverse, wouldn't the inverse be 1, negative 2? Do we agree? Okay, when you have a function and its inverse, we switch our domain and range, but it's also a reflection. Does anybody know to get from this yellow or this blue point to this red point, what we're reflecting over? Ariana? You got it. We are actually reflecting over the line y equals x. And the line y equals x has a y-intercept of 0 and a slope of 1. So if you look at this, if we're reflecting over the line y equals x, it's almost like we're folding the paper over that line and creating a mirror image on the other side. If I'm folding the paper over this, that creates that 0.1, negative 2. That is not a coincidence. That is always the case. Whenever you plot a function and its inverse, you are literally reflecting it over the line y equals x. All right. Let's write that out, actually. To find the inverse of a function, is the same as reflecting the function over the line y equals x. Okay, so now visually we know what's happening when we have a function and we get the inverse. We know visually we're reflecting it over the line y equals x. We know if we're given a set of points to find the inverse, we can just switch the x coordinate and the y coordinate or switch the domain and range, right? All right, now let's figure out how do we find the inverse algebraically. So that's our next part. So to find the inverse of a function algebraically, I'm going to tell you what we do. Step 1. We are going to replace f of x with y. And we know they're interchangeable, so I'm not really changing anything. We know f of x and y are the same thing. If it's already a y, we're going to leave it as a y. So our first step is replace f of x with y. Our second step is going to be to switch x and y, which makes sense because when I give you a set of points and I say find the inverse of these points, we literally just switch x and y. So it makes sense if I'm giving you an equation, we're going to switch x and y. Our next step, after we switch x and y, is we're going to solve for y. Once we solve for y, then we're going to replace y with the inverse function, which is f raised to the negative first power of x. That's how we represent the inverse function. And we're done. Now I'm going to put a little star here, and I'm going to make a note. The inverse of a function is not always a function. When I say it is not always a function, does that mean that it could sometimes be a function? Absolutely, but does it have to be a function? No. And now let's go back and talk about what criteria makes something a function. What criteria makes a relation a function? Who remembers? Go back.
Each x maps the
Good. Every x has exactly one y, or every domain has exactly one range, right? So it means I can repeat x, but I cannot I can repeat y, but I cannot repeat x, okay? So every x has exactly one y. We can repeat y, but I cannot repeat x. That's what this is saying. We cannot repeat our domain. Okay. So let's start off. If I give you a graph, how do you check to see if it's a function or not? Amanda? The vertical line test. Excellent. So let's jump right into this. Let's do some sample problems. So for all of these directions, I want us to find the equation of the inverse. Or actually, I'm actually not even going to just write the equation. I'm going to say find the inverse. Sorry. So here, if I have f of x is equal to 3x plus 5. If I were to graph this, what would it look like? F of x equals 3x plus 5. Violet? Yeah, what is that? Is it a parabola? It's a line, yeah. So if I have f of x equals 3x plus 5, this is absolutely a line. So now I want to find the inverse. When I say find the inverse, I mean the equation of the inverse. But before I find the equation of the inverse, what determines, we've been learning this from the last class, what determines a lot of how something looks when we graph it? Do you remember what determines? Yes. The domain. Remember, the domain took our shooting stars from passing each other, right? When it was a non-standard form, from passing each other to stopping at meeting each other, right? So the domain absolutely affects how the graph looks. So the domain has to be part of our inverse. So to find the domain of our inverse, I first have to find the domain and range of the original. Well, do we agree that the domain, since it's a line of the original, there's no restrictions here on this domain? There's no variable in the denominator. There's no square root. So our domain is all real numbers. All right, now, in order to find the range, generally we graph it, but you don't always have to graph it. You could visually try to see what it looks like. And since this is a line, we can figure out the range without graphing it. What is the range of a line? Ariana? All real numbers. So now when we go to find the inverse, the domain and range play a big part. So now we're going to say the inverse, so domain of inverse, well, isn't the domain of the inverse the range of the original? Well, the range of the original was all real numbers, so the domain of the inverse is all real numbers. And we're also going to say, what is the range of the inverse? Well, the range of the inverse is the domain of the original, which is all real numbers. Do you think it's always going to be this simple? No, we'll see in future problems how it changes. Okay, so now we're going to find the equation that goes with the inverse. So our steps say take f of x and replace it with y. So I have y equals 3x plus 5. That was our first step. Our second step says take x and y and do what with them? Switch them. So I'm going to have x is equal to 3y plus 5. After I switch x and y, I can't stop here. What is my next step? Solve for y. So when I solve for y, I need to get it all by itself. So I'm first going to subtract that 5. So I have x minus 5 equals 3y. And then I'm going to divide by 3. So y is equal to x minus 5 over 3. And what is our last step after we solve for y? Our last step. Leo? Yeah, replace y with the inverse function. So f to the negative first power of x is equal to, guys, we could leave it like x minus 5 over 3, but I just want to show you. I could also write it as 1/3 x minus 5/3. Both of these are acceptable. And normally on a test, I'd probably just leave it like x minus 5 over 3. But why do you think I wanted to write it like this just for today at least? Yeah, so you can see that it's a line. And doesn't that make sense that the inverse of a line would be a line? Because if I'm taking a line and I'm reflecting it over y equals x, aren't I still getting another line? It makes sense. And now, because this is a line, let's go back and see if my domain and range are fitting. Well, if this is a line, my inverse function is a line, does it make sense that my domain is all real numbers and my range is also all real numbers? Yeah, because we're extending arrows in both directions. So this makes perfect sense. Now, I cannot stress this enough. When I say to find the inverse, the domain and range are part of your answer. So if you were to just write the equation without the domain and range, you will get a significant amount of points off. The domain and range are part of our answer. So you could write the domain D of f negative 1 of x is all real numbers. The range of f negative 1 of x is all real numbers. And this whole answer is this whole box that I boxed off is our answer. Okay, let's do one that's not so straightforward. Are we ready to step it up? Maybe, maybe not. All right, let's do a next one. Let's say I have f of x is equal to the square root of x plus 3. Visually, what does this look like? A shooting star, exactly. This is a shooting star, and you don't have to sketch it. I'm just going to sketch it for you real quick. This is a shooting star that's been moved 3 units where? To the left. So we know it looks something like that. Do we agree? Okay. So now, if I have f of x is equal to x plus 3, I need to find the domain and range of f of x. Why do I need to find the domain and range of f of x if I'm asking you for the inverse? Why is this an important step in finding the inverse? Anybody know? Somebody different, somebody besides Ariana, have a thought. Why? I'm going to repeat the question. Why do you think it's important if I'm asking you to find the inverse? Why do I have to find the domain and range of the original function? Well, good, because the domain and range of the original function gives me the domain and range of the inverse because we switch them, right? That's the only way I'll know the domain and range is if I find the domain and range of the original. So now, since we have a little visual going on, do we agree that the domain of f of x is what? You tell me, what is the domain of f of x? Mishka? You got it. X such that x is greater than or equal to -3. What is the range of f of x? What's the range of f of x? Since we have our visual, it's easier to identify. Violet? Wait, say it one more time. Perfect. Can I just write y is greater than or equal to 0? Yep. So what Violet said was absolutely perfect too, and it's also in set notation. She said y such that, did you say negative infinity is less than y, which is, I don't know if you said less than or equal. Sorry, I did this wrong. Our lowest point is 0, so we're going to say 0 is less than or equal to y, which is less than infinity. We want to make sure that that 0 is equal to. Okay, are we now ready to find our inverse? We should be. So now let's find the inverse function. So my first step in finding the inverse function is to take f of x and replace it with y. So I'm going to have y is equal to the square root of x plus 3. Who remembers what our next step is? Violet? Good. We're going to switch x and y. X equals the square root of y plus 3. Now, our next step after this is to solve for y. So now let's think about this. In order to solve for y, do we agree we need to get rid of that square root? To get rid of that square root, what do I have to do to both sides? Square. To undo a square root, we're going to square both sides. So I'm going to go ahead and I'm going to square the right side and the left side. So I'm going to end up with x squared equals y plus 3. My goal is to solve for y. If my goal is to solve for y, do we all agree I need to subtract that 3? So I'm going to get y is equal to x squared minus 3. My last step here is to replace y with f of x. Sorry, not f of x, the inverse function of x. Is this my answer? No, this is not my answer. What did I tell you has to be part of your answer? The domain and range of the inverse. How am I going to identify the domain and range of the inverse? It is based on what? The domain and range of the inverse is based on what? Somebody besides Ariana and Violet and Vivek, somebody else tell me. The domain and range of the inverse is based on what? Good, the domain and range of the original. So now when I want the domain of the inverse, we know it's what to the original. So the domain of the inverse is what of the original? Amanda. The range. So we know the domain of the inverse is the range of the original. So now my domain here, I can't put y, right? Because domain is always x. So it's going to be x such that x is greater than or equal to 0. A lot of students on the test will still write y. You can't write y for domain. Domain is always x. We're just using the numbers from the original range. And now the range of the inverse is the domain of the original. So now I'm going to put y such that y is greater than or equal to -3. let's talk about this for 1 second. Oh, was there a question? Yes.
Do you have to write it in set notation?
No. Yep, whatever notation you want. Ariana, was that also your question? Correct. Okay, so now, guys, I want to talk about this because I don't want us to be robots. I want us to think. So right now, my original, we knew was a shooting star. It was a shooting star that's been shifted 3 units to the left. We all agreed on that. But now when I find my inverse equation, what is it saying it is? Karen? This is a parabola. Does that make sense? Can the inverse of a shooting star be a parabola if I'm just reflecting it over the line y equals x? Does that make sense at all? No, but guess what? Even though this is a parabola, it doesn't look like a parabola. Why doesn't this look like a parabola when we sketch it? Why doesn't it look like a parabola? Go back.
Because the domain is restricted.
Because we have a restricted domain. Guys, you don't have to do this right now, but you could watch me. Let's just sketch this, okay? Let's sketch this to see what this sketch would look like. So if we are sketching the parabola itself, do you agree that we are moving 3 units down? I'm going to find my x and y intercepts. So for my x-intercept, I'm going to go 0 equals x squared minus 3, 3 equals x squared, x equals plus minus the square root of 3, which is going to be somewhere a little bit less than 2. So I'm going to say plus minus, let's say like 1.7. I'm just making up between 1 and 2. So we are at around here and around here. So it looks something like this. We already know our y-intercept because I shifted 3 units down. Do we agree? Okay, but now the domain is restricted. What is the restricted domain telling us? The restricted domain is telling us x is greater than or equal to what? 0. So that means everything that's less than or equal to 0 is not part of my graph. And even though it's not completely accurate, we have went from a parabola to a shooting star. Okay, do you see why the domain and range of the new function is so important? Not so much the range, but the domain, why the domain is so important. Yes? No? Maybe? Yes? Okay. So this is why that domain is part of our answer. Our inverse function is not just x squared minus 3. It's x squared minus 3 with this restricted domain and range. Okay, so now what I want us to do is I want us to graph the function and its inverse. Okay, let's say I have g of x is equal to the square root of x minus 1. Well, now if we're getting a visual of this parent graph, of this shooting star, my parent graph is a shooting star, but I'm shifting 1 unit where? To the right. So it looks, this is just an idea, right? It's not completely accurate, but it looks something like this. Do we agree? Okay. So now I want us to list our domain and range. What is the domain of g of x? What is the domain of g of x? Ira?
Such that x is greater than or equal to 1.
Perfect. What is the range of g of x? Leo?
Y is such that
Perfect. Okay, so now that we know our domain and range of the original, we'll be able to figure out the domain and range of the inverse. So now let's go ahead and find our inverse. So now our inverse is going to be, I take y equals the square root of y equals the square root of x minus 1. I'm going to switch x and y. And now we're going to solve for y. So to get rid of that square root, I have to square both sides. So I have x squared equals y minus 1. And then I'm going to add that 1 over. So y is equal to x squared minus 1. So now we have the inverse function of g of x is equal to x squared minus 1. Oh, sorry, it's plus 1. Thank you for that catch. Is this good enough for the equation of my inverse? Absolutely not. The inverse of a shooting star will never be a parabola. What changes this parabola from looking like a parabola to looking like a shooting star when I come to graph it? Amanda? The domain. So now I have to include the domain and range of the inverse. So the domain of the inverse function is the range of the original. So I'm going to say x such that x is greater than or equal to 0. And the range of the inverse is the domain of the original. So y such that y is greater than or equal to 1. And now they asked us to sketch both of these. It says graph, but it's really not an accurate graph. We're still just sketching. So my original, I know I was moving 1 unit to the right. And we're shooting up. Something like that. Like I said, it's not completely accurate, just an idea. Evelyn, you with us? Okay, now the inverse. So now what's going to help us here is the, I guess we could graph the parabola and erase, or I'm going to do it both ways. Let's graph the parabola and erase, and then I'll tell you the other way I would graph it. I could sketch this quicker. So if we're graphing the parabola, we all agree that I have moved 1 unit where for the parabola? Up, 1 unit up. And then we're going up to the left and up to the right. Do we agree? But because of our restriction, x must be greater than or equal to 0. What am I erasing? The left part of this. So it looks something like that. And wouldn't that sort of be like how it would look if I was folding it over the line y equals x? It would look something like that. It's a general idea. All right. How else could we have done this, or how else can we check this? Remember, the only point I have in the original is the point 1, 0. When we're taking the original and finding the inverse, what do we do? Don't we switch x and y? So the inverse of the point 1, 0 is the point 0, 1. And then we know we're reflecting it, so it would have to look something like that. So that's also how you can check this, or do it and then check it the other way, however you want. All right, guys, I'm actually going to stop here because I don't have enough time to finish the lesson. So I rather just stop here. And because we didn't finish, you don't have any homework.